Hello, this is Brian from Tavaran Games here with part 2 of our strategy game map generating tutorial I've been working on. So in this one, I want to cover the camera controls. So you can see we can zoom in and out, and it will try to keep the mouse positioned over top of whatever tile you have it currently positioned over. You can also grab the map with a mouse button, so middle mouse button and right mouse button are what I've keyed it to, and drag the map around. And you can use the arrow keys to move the map around. It's also bounded, so the map cannot vertically go above and below the plane, and you can't zoom out past the plane, and you can't zoom in super far. So I want to get all that covered in this tutorial. As well, I would like to get the map wrapping, how I've got the tiles to always position, so you can just keep scrolling and scrolling and scrolling forever in one direction, and it just keeps repeating, and how I did that. So hopefully I've got time for both. So let's go into our tutorial version of the scene, from where we left it. And let's immediately create a new script called camera control. So this is going to be the controller for the camera. So let's attach it to the camera itself. Cam control. Okay, so the first thing we're going to try to do is get the keyboard inputs working. So we're going to actually be using the raw axis inputs that Unity has built in. So we're going to set a float of horizontal, just hori for horizontal, and we're going to set that to input.get axis raw, and we are going to grab the horizontal, if I can spell, axis, and we're going to do the same for vertical. So vert equals input.get axis raw and vertical. So these axes are built into Unity. Horizontal set to left and right, and alternate to A and D, and that should be equals. And then vertical is set to up and down, arrow keys, and W and S. So we're also going to need to set a vector 3 of our camera's position. We're going to use vector 3 because the camera does actually have a Z position. So we don't want that getting messed up. I've had times where it changes for some reason as you are messing with other things, and that usually is fine, but once in a while it actually moves to the wrong way on the axis, and you can't see anything on the screen anymore. So we're going to grab the position as the vector 3 of the transform. And now let's check just a simple if statement. Not input. If horizontal does not equal 0 or vertical does not equal 0. So or is the two vertical lines. 0. And we're going to check those. And if they're not 0, we are going to modify the position. We're just going to do it both at once. So pause.x plus equals hori times time dot delta time. If you don't know what delta time is, this is just a little function that tracks the time of a frame of a computer. So it's just 1 over the frame rate. So if a computer has a very high frame rate and you just add horizontal, then the camera might move way too fast, and the player won't really be able to control it or stop it in time. So, and if a computer has a very low frame rate, and it's adding on just a little bit of horizontal input each time, then they might feel that the game is way too sluggish. So if we multiply by the time.delta time, slower frame rates will add more x value per frame, and higher frame rates less. So each player will see the same amount of movement per second, regardless of their computer's frame rate. So it's very useful anytime you're doing movement in a video game to take the time.delta time into account. So we've got that. And now we're just going to apply that back to the transform. So there we have it. So this is the most basic possible movement we can do. Let's just jump into the game, let it compile, and let's move. And there we go. Look at us go. We're rocketing around. But because we are multiplying an input that's between -1 and 1 by the frame rate, we are getting very slow movement. So let's fix that. We're going to do it with a public variable. So just public float speed, and we're going to make that equal to 10 for now. We're going to test it with 10 and see how that works. So we're going to multiply this by speed, and we're going to multiply this by speed. And there we go. So let's do that. Save it back into the game. All right, hit play. Okay, let's start moving, and there we go. That's a lot better. So we're moving at a pretty good clip. We can move around the map. Here you hear me scrolling by instinct when we haven't put that in yet. So we can change the speed to 20, and you can see the camera moves much faster. That's a bit too fast. It's looking a bit blurry to me. Set it to 15, and we get a pretty nice speed. So yeah, we can change the camera speed at will. So yay, we have our movement. But what's the other thing we want right now? Well, scrolling, as I just mentioned. So if we go into edit in our project settings, we can see under the input manager and the axes that we have a mouse scroll wheel as an input axis. So we can grab that. Now the sensitivity is default set to 0.1, which means each click, each time your scroll wheel clicks, it's going to register 0.1 or negative 0.1. And then, so we know that, we can use that in our code. So how do we actually zoom? If we change the z-axis of the camera until we get really far away, we can't really see it, like once we're past the clipping plane. So it's not the z-axis we change because we're in orthographic perspective. So instead it's the orthographic size that changes to change zoom. We set that to 10, you can see we zoom out. If we set that to 2, we zoom in. All right, so we know that now. We're going to need to grab the camera as an actual game object. So we're going to set camera, cam. So this will be our camera script. So cam equals get component camera. So we already have the camera component attached to the camera, so we are good to go. Now the other thing we grab, of course, is that input. So we float the scroll as an input. Get axis. It's mouse space scroll wheel with a capital W. There we go. Almost forgot. So we have the scroll, and we know that each time it clicks, it's going to be 0.1 or minus 0.1. Okay, so we're going to want to change the orthographic size of the camera when we scroll. Now, we're actually going to check the scroll as two separate things. We're going to check when it goes negative, when it's being below 0, so negative 0.1. That means you're pulling the scroll wheel toward yourself, which is down, like this. And then the positive is up. So we want to zoom out as we scroll it down. That's pretty much the standard in most programs. So this scroll less than 0 is going to be zooming out. We're going to keep it as a separate if statement, even though the code in each if statement is going to be the same. The reason for that is so we can bound the orthographic size. Now, we don't know how far we want to zoom out yet, but we do know for when we zoom in how far we want to zoom in. As you saw, when we set the zoom to 2, it's pretty darn close. So that's about the limit for approaching it. Let's actually stop that. So if the scroll is less than 0, we're going to take the cam.orthographic size, and we're going to subtract the scroll from it, and we're going to multiply that by 10. So the reason we're doing that is because it's at negative 0.1. It's 0.1 each time it clicks. Multiplying by that by 10 will mean it will move 1 every time you click in zoom, and I've found that that ends up being a pretty nice rate of zoom. Okay, so simple as that. We're going to have it in brackets for now instead of my classic ignoring the brackets when it's only 1 line, because we are going to add more information there. Now, we also know we're going to do this as an else, so it doesn't always check, because we know that scroll is can only be less than 0 or greater than 0 or equal to. Now, in this case, though, we want to also make sure the orthographic size of the camera, actually put size in, is greater than 2, because we don't want to zoom in too far. Okay, now we do the exact same code though. We're going to subtract the scroll. The reason we're subtracting it is because zooming out is increasing the orthographic size, but pulling back on the scroll wheel is sending a negative value for the input, less than 0. So we have to subtract the scroll times 10. And same thing when we're zooming in. So I know this looks a bit funny that we've got the exact same code in each, but again, the reason for that is because we want to add these bounding box statements into each if statement. Okay, so that's our very basic scrolling. Let's go into the game. Let's run it. Oh, I hate when I do that. Let's get it going again. So you see we can scroll out, and ooh, we can scroll out forever, and we can scroll in. Now, we're not approaching the mouse. It's going to scroll at whatever the camera position is, 0, 0. Now, one thing, though, as we zoom out, you can see we're now feeling like we're moving pretty gosh darn slow. That's not ideal. We want you to move fast when you're zoomed out. And then when we're zoomed in, we're moving pretty fast. So let's alter the speed variable as we zoom in and out. So we know that the default zoom is set to 5. And then the speed of 10, I mean, maybe that's a little slow for 5. Let's say 15. So let's zoom all the way in. Let's set the speed to 12. I mean, that's not too bad, but let's find out where we really want to be. If the speed's 5, that's a little slow. I don't like that. 8 actually feels pretty good. This will just give us a rough idea. And now, the furthest we want to be zoomed out is maybe here, an orthographic size of 9. Yeah, that looks pretty good. And so a speed there, if we set the speed to say 20, that's not too bad actually. I kind of like that. We might want to be a little higher, maybe like 26. But either way, we want to be adding to the speed each time we scroll. So we can do that very simply. Speed plus equals, in this case, sorry, minus equals because, or no, as we're zooming out, we want to increase it. So let's set our default speed to, I think we found maybe 13 works pretty well at, well, we're at 5 and we liked 8. So yeah, 13. So equals, and then the same thing, scroll times 10. We're going to add that. Get rid of that bracket. We're going to copy that. Again, it's the same code in each, it's just the bounding box. So that'll compile. We have to stop it, start it up again, otherwise it gets all mad at us. So the speed looks pretty good. So this is our speed at zoom 5. And now we zoom out. Oh, we have those backwards. So we need to subtract. Right, scroll is negative. So we're going to subtract the scroll. You've seen my mistakes. There we go. It's doing the exact same thing as the camera. Okay. Let's do it again. Zoom out, and there we go. We're moving a bit quicker. That feels better. So the more we zoom out, the higher our speed. And the more we zoom in, and slower speed. So it feels pretty good. That's not bad. You can play around with the numbers and how much you're subtracting and all that until you get something that feels nice. But okay, let's bound our top orthographic size. So to do that, like if you look, we have the map. Now this map is 20 tiles tall and an orthographic size of 9 is pretty good. So we want to figure out though, how do we do that? Like let's say the map is 30. So let's generate a map that's 30 by 60 and generate. So now we have a bigger map and let's just check and let's make sure. So an orthographic size of 14 looks pretty good for a map of 30. If we zoom into 13, it's a little tight. It would be cutting off a tiny bit. So 14 works pretty well. So it looks like what we want is the zoom to be the size of the map, the vertical height of the map divided by 2 and then subtracting 1 from that looks pretty good. Now let's try, say, we can try that for 25. So 25 won't work easily. So for 26, it would be 13 minus 1. So it would be 12. Let's generate. And let's see. So 12, again, pretty good. So the rough math works out. So let's do that. So firstly, we need to get the map width. Well, we know that the map maker script is also attached to the camera. So we can set an integer to the height of the map, sorry, not the width. We will just set a default value, again, the same as we used before, of 20, but this will change in it. So what we can do here is when we start, we can grab the map maker. Map maker. Oop. And so we want to get that, and I actually completely forgot. So, I am not saying well. So height is equal to get for map size dot y. So that gives us our height. Now the other thing is though, oh yes, we have to make sure cast that as an int. I always forget to do that. And there we go. That's nice. So we can get the height. The other thing we want to do, just because we know we can generate different times, so I added in some comments here, just FYI. So we get the height here. And we have the camera. Do we have the camera here? No. So what we will do is we're going to get the camera. Dot find game object with tag. And then we can grab main camera. Just the default tag. And we are going to set the height. Did I make that public? I did not. So we need to make this public so that our generate script can access it. All right. And then height. Get component. Silly me. Get component. The cam control. There we go. Dot height is equal to map size dot y. Okay, there we go. So now when we generate the map, the height, again, integer. The height will be set every time we generate the map using that generate button. So we know that what the y is, what the height is. So on this side, we want to make sure cam.orthographic size is less than, basically we want the map height, so the height divided by 2. Now, because that's an integer and the 2 is an integer, this will automatically be an integer. Let's bracket that because then we're going to subtract 1 from it. And that should give us the correct zoom out. So let's save that, go back in, stop and start this guy once it's ready. There we go. Okay. And that should bound it to about 9. Perfect. So it's bound to 9. Let's change the map size again to 30. Let's make it wide as well, just so it actually fits nicely. And we can see we are bounded. So we can't overly zoom out. We can zoom in, we can zoom out. The map speed changes, how much we move, all that. Okay. So we've got zooming. And again, we're not going to bound it, the vertical movement quite yet. We're going to get to that soon. But we have to be able to move it with the mouse. I can click and I cannot drag. And that would be infuriating in a map make or a strategy game. You got to be able to click and drag the camera. So what we're going to need to do is we're going to need to grab the mouse input. Now we can use the the Fire 1 and Fire 2 axes, or we can just grab the mouse input. Up to you which you want to use. I like to get the horizontal and vertical from the get raw axis because it gives you the negative and positive in the same thing. With the mouse, we're just looking for button down and button up. And we want both, because on a button down, we want to start moving, and on a button up, we want to stop moving. So we're going to need a couple of variables. So the program needs to know when the mouse, like when it's supposed to be moving with the mouse. So this one is going to just be a bool, and we're going to call that mouse move. So this will tell it that your mouse is trying to move the camera. So right now it's false. This way we're not always trying to check, has the mouse moved? Do we need to move it? Have you clicked? All that stuff all the time. The other thing we want to have is we want a vector of where the mouse was. Yeah, we'll call it mouse pause, that'll work. So we need to know where the mouse first started clicking so that we can move the camera in relation to where the mouse was. Okay, so we've got that. Lovely. So we need to get the input buttons for mouse movement. Now we've got all this fun stuff. Let's just add it in. So in this case, we're going to just check it if the mouse has been clicked. So if input dot mouse button down, so get mouse button down, and we want this to be on either the middle mouse button or the left mouse button. So that's 1 and 2 as our inputs. And we're just checking this as an if. If it's been pressed down, we're grabbing this. Or this is firing as true. So we know we now want to move with the mouse. So we're going to set this to true, and we're also going to log the start position. Mouse pause is equal to what we need is we need the camera which will just be the default camera. If you just type in camera, it's the default camera. Now, honestly, I could have probably used that up here instead of get component camera. I always forget this. But we will do screen to world point. I accidentally clicked the quotations. And then we need the mouse position. So that is input.mouse position. So what that's going to do is it's going to translate the mouse's pixel coordinates, which is input.mouse position, to the actual coordinates in the game world from where the camera sees it. So we will have a vector 3 of what the mouse is actually pointed at in the camera's eye. Okay, so now we need to move it with the mouse. Okay, so we're not going to comment, but we know the variable. So if mouse move is equal to true, we're then going to want that. So we need to check the change in position of the mouse. So we're going to do a vector 3, and we're going to call that delta pause for the change in position. So we're going to grab this same input, the new mouse position, and then we're going to subtract from it the original mouse position. Okay? And now, we should actually do this after pause, I just remembered, because we are going to modify pause, the position. So there we go. Put that in the wrong spot. So we know the pause is the transform position, so we're going to subtract the delta pause that we calculated here from the mouse position, so that way it will move away from the mouse. So if you click and then drag the mouse to the right, the camera will move to the left, so the world looks like it's moving right. If we add it, then it moves inverse to the mouse, and that I find doesn't feel as natural. As with the other inputs, we're going to want the time.delta time, and then we're going to want to times by the speed. Now, maybe this might be too fast. might not be. We're going to find out. So again, we're going to pop into the game. We're going to hit play. I just, realized, before we hit play, I forgot, we need also the input up to stop the mouse moving. So instead of mouse button down, we're just going to copy this, and then we're going to get mouse button up. So this is when the mouse is released. We definitely need this, otherwise once you click once, it's just going to be glued to the camera, false, and we can get rid of that. And we actually don't need the brackets, because we only have the one statement. Alright. Now let's go. There we go. Okay, so I'm going to click middle mouse, drag, and it's moving with the mouse. Now it's moving pretty quickly with the mouse, but that's not bad. So it's trying to move the map and basically keep the mouse in the same position as it moves. It's pretty close. We can modify that speed value if we want. We can see it moves pretty quick. Now when we're zoomed out, that's pretty good. So we can change the way it interacts with the speed, but if you look, I mean, it's staying pretty much exactly tracking the mouse, and it's only delayed a tiny bit, which actually is kind of good because it gives us that little bit of delay, so it has a little bit more of a mechanical feel, like you're actually dragging something with some weight. But there we go. We have our mouse position nicely. Okay, so now that we're actually tracking mouse position and you can move with the mouse, what was that other thing we did before? You saw in my previous game that I had it set as you zoom in and out, that the game tries to keep the mouse in the same position. So in order for us to have the camera move sort of towards the mouse as we're scrolling, we need two things. We need to know what the tile the mouse is pointed at, and if the mouse has moved in pixel relation. So we're gonna have a couple variables. I found that it works pretty well this way. So we need the desired position. So it's a vector 3, new vector 3, and we'll just set that to 0, 0. Oop, too many commas. And we're also going to track what we call the old mouse, which is the old mouse position. And then 0, 0, 0 as well. Okay, so we need to actually set our desired position on each frame. So we only want to do that, though, if the mouse has moved. So we're going to use the input.mouse position, which is, of course, the pixel value of the mouse position. And we're going to be using old mouse to track that and whether it has changed. So we're going to change the desired position only when the player has moved the mouse pixel-wise, so on the screen, not whether the mouse has moved in terms of the coordinates. Otherwise, we're going to basically, every frame, it's just going to reset the desired position to wherever the mouse is coordinate-wise, and we're not going to get any type of zoom. So whenever the player moves the mouse pixel-wise, we are going to be changing the value. So first we have to actually track the new position, again, to make sure we are only changing this when the mouse position changes pixel-wise. And then we're going to set the desired position equal to the screen world point, so the actual coordinate position of the mouse. So the desired position is only being set when the mouse is moved as an input, as a coordinate. Okay, so we want to track towards that. So we need a new vector 3. Again, this is, so delta pause, we've used something similar. And we're going to take the desired position, and we're going to subtract the current mouse position coordinate from it. So again, the desired position is set when the mouse is moved. So this way, if you move the mouse, it resets that, and it starts tracking towards whatever the new position is. But again, if you're not moving the mouse, we are not changing the desired position. This is in the wrong spot. We want this in the scrolling area. Okay, here we go. Copy that, put it in the scrolling area. That's where it's supposed to be. And then we can set the pause. We're going to add on the delta position to the pause, and this will cause the camera to try to track towards this. And it's going to track a little bit at a time. And again, we need that in both, so we'll save that. Okay. Let's see if that works. Let's hit play. Okay, so let's put the tile over this, and look at that. You can see that this mouse stays over that tile no matter what. We go over this tile, the mouse stays over that tile. Over this one, it stays over that tile. Again, we're not zooming so that the mouse ends up in the middle of the screen. We're zooming so the mouse stays on whatever tile it is hovering over. Bottom of this peninsula, look at that. So that's it. Simple way to have your scrolling track in nicely with the mouse. Awesome. So let's get the whys the Y bounded up, so we can't just keep scrolling up and then, oh, no more map. All right, let's go into it. So we need to bound the Y position, and we're going to do that sort of right here before we actually set the transform position equal to our position. So we're going to need some type of number, if I can spell it correctly, that is the minimum Y value. We're just going to set that to 0 for now. We need another number that's going to be the maximum Y value, and we're going to set that to the height. And then we can just use a pair of if statements. So if pos.y is below the, not 0, min Y, we can then just make pos.y equal to min Y. And we can check here if pos.y is greater than max Y. We can then set pos.y equal to max Y. Okay, so this will bound the camera between whatever we set min Y to and whatever we set max Y to. So we're going to brute force this a bit. Let's go back into the game and let's figure out where those need to go. So let's get a map going again. Okay, so we're at zoom level, if we look here, of 5, and that 0 is a little too high. If we zoom in, we're at 2, that's not too bad. It's not perfect, but then, way too much on top. So those definitely aren't the bounds we want, and the bounds are going to depend on zoom. So like this isn't so bad when we're zoomed all the way out, but as soon as we zoom in, we lose everything at orthographic size 2. So if we're actually looking, let's look at this. And if we're at orthographic size 2, position of 1 looks good. The bottom is in a nice place. You can see all the tiles and not too much extra map. If we go to the top, we move up here, it's looking like around 15 is pretty good if we're thinking of it in integer values. Really, it's about 15.34 gives the exact same amount of space on top. So where does that come from? Well, if we just look at the scene, the top value, it's just 1 minus the top value of 16.34. So we can work with this. We know that this top value is the height of the map times 0.86. So we know that when we're at zoom of 2, we want a bottom value of 1. Again, let's go back to the game, and let's try a different zoom level. If we're at a zoom of, again, got to select the camera, of 2, again, 1 is good at the bottom. If we go up till this is 1. If we zoom out to 3, putting that at 2 leaves a good space there. And remember, we had 16.34. Let's take away 2 from that to 14.34, and we have about the exact same amount of space on top. So we now know our bounds. We know that the bottom bound is going to be this orthographic size minus 1. And then the top bound is going to be the total Y height in a float value minus that. And then if we're at zoomed all the way out, so we get this 8.34. Now our zoom level of 9 would mean that this would be 8 to 8.34. It'll be able to jiggle a little bit. So that's something we can fix in a second. But let's just get this strategy in place. So we know we have the camera already set. So let's go to the orthographic size. And we're going to subtract 1 from that to get our minimum Y. And now we know this height. Well, we want to make that 0.86. Well, let's actually do that here. And we're going to fix this zoom at the same time. So we know that this is mapsize.y, well, times 0.86 f, we'll do that. And then we got to change this from an int to a float. Again, the only reason we're using the height is to bound the box and determine the zoom levels. Let's get rid of the int value here. And so we now have that, I have to spell right, as a float. And again, this is, we said 20, really it's got to be 16.34, and this will make it that. Now, we also need to do that on the map maker where we do this. And so we're going to get rid of this integer, and we're going to multiply this by 0.86f. And I'm realizing that this is on the camera as well. So actually, we can get rid of that. And if you saw that earlier and were just calling me an idiot for that, yeah, you're right. I didn't need to do that. So we can just get the cam control and set the height to being the actual height of the map instead of this integer value number of tiles. So now we're going to want to fix this sort of zooming here. So we've got the orthographic size is being moved in units of 1. That's to speed it up and make it scroll a little faster. But we're going to want a little more fine-tuned. So let's multiply this by 5. So we move in factors of a half. And now let's go here. So if we divide the height by 2, the height is now, if it's up to 20, is going to be 16. So if we divide that by 2, well, 6.34, it gives us around 8, which is too low, actually. We want the zoom we found that was good was at 9. So instead of subtracting 1 right now, we should probably add 1. So we can do that. And now if we go down here, we know we want the minimum Y to equal to the orthographic size from the camera. Size. And then we want to subtract 1 from that. And then we know that this is meant to be the height minus the minimum Y. Oh, whoopsie daisy. Not capitals. So we have that. So the scrolling is now going to be a little more fine-tuned. It's going to move in factors of a half. And then we're going to change up our bounds here. And let's just see what that looks like. Let's turn this back on and see if that's where it should be. So scrolling down, I'm trying to move down, and it looks okay. I try to move up. That's not too bad. It's a little higher than I'd like, but it's pretty good. If we're here, we can't scroll up and down. I'm trying to move up and down. It won't let me. And it's locked in. The zoom level is not bad. That's a little higher than I'd like. I don't know why it can go to 10. It should be stopping around 9.5. But that's okay. I'm okay with that. So that looks pretty good. So let's make this bigger map. And do this to 60, generate that. So we have a bigger map now. Again, we're locked in vertically if we're zoomed all the way out. If we zoom in, again, we can zoom so that these tiles are kind of at the top and zoom out kind of at the bottom. There's a little more space up here than is ideal, but you know what? That's pretty darn good. The scroll is still pretty quick. I'm liking that. So again, I actually was modifying this from my original code as we're sitting here problem solving. So we're improving my own game on this through the tutorial. But okay, given that this tutorial is now quite long and probably over half an hour at this point, I think we'll stop it there. We will do the map wrapping in a future tutorial and getting it so that as you scroll to left and right, the tiles actually wrap around so that you get a nice continuous feel of a rounded map, of one continuous world, as if you're sort of rotating around a cylinder. So we'll definitely get that done in a future video. We'll also start adding the terrain features. But yeah, if you made it this far in the tutorial, thank you for watching. I hope you learned something. We have a nice moving camera now. If you can think of any better ways we could have done this, please let me know. Anyway, have a good one.